In this video, we're going to do an example that combines a couple of techniques of integration. In particular, we're going to first do a substitution and then use integration by parts. So in this one, we want to evaluate the integral from 0 to pi of e to the cosine t sine 2t dt. All right, so the first thing to recognize is that we can probably do something from a trig identity standpoint to rewrite sine of 2t. And if we remember our trig identity, we know we can rewrite sine of 2t as 2 sine t cosine t. The reason I did that in this case is because it's really going to be helpful for us to have the argument inside the sine and the cosine to be the same. All right, so our most obvious candidate for a substitution here will be the exponent here up in the exponential. I don't want to call it u because we're going to use integration by parts and we use u there, so I'm going to call it w. I'll do a w substitution. So if we let w equal cosine of t, then dw is negative sine of t dt. We've done now a substitution here, so I need to make sure I change my limits. If I'm going to change these to w, my limits needs to be in terms of w as well. Plugging in 0 for t, we get 1 out for w. Plugging in pi in for t, we get negative 1 out for w. So now when we make our substitution, here is where we apply the trig identity. Cosine of t is our w, so we'll get w e to the w. That's where that piece is coming from. We can pull the 2 out in front, and we can do negative dw for sine t dt, and that's where the negative sign is coming out in front. It's adjusting for the negative that I need for the dw. So we get negative 2. And then we plug in our different endpoints. When t was 0, w was 1. When t was pi, w was negative 1. So the 1 is our lower limit of integration. The negative 1 is our upper limit of integration. And the integrand is w e to the w dw. The negative in front here, we can use that to flip our limits of integration, make it look a little bit more standard, putting the lower number on the bottom and the higher number on the top. And now for w e to the w, we can use integration by parts. We'll let u be w, then du is dw. dv then is e to the w dw, antiderivative is just e to the w. Apply our integration by parts formula, making sure we plug our endpoints into each piece. Find an antiderivative for e to the w, which is e to the w. Plug in our endpoints and simplify. You should get a final answer of 4e to the minus 1.